Hello everyone. In this video, we'll be solving the numerical problem in Cartesian coordinate system for boundary value problems based on Laplace equations. The question says in Cartesian coordinates, the potential is a function of only x and the boundary conditions are given. First boundary condition is at x 2 centimeter, voltage is 25 volt, and at x 2 centimeter, electric field intensity is given, which is minus 1.5 into 10 power 3 volt per meter. We are asked to find voltage at 3 centimeters using Laplace equation. So two boundary conditions are given, but the two are not given for V. One is given for V, another is given for electric field intensity. So let us write the boundary condition first and then proceed solving this problem. So first boundary condition is at x equals to 2 centimeter. So I will convert it into meter and write 2 into 10 power minus 2 meter. Voltage is 25 volts. And the second boundary condition says at x equal to 2 centimeter, 2 into 10 power minus 2 meter. So let me write it properly here. Electric field is minus 1.5 into 10 power 3 ax cap volt per meter. Now we should start from the Laplace equation in rectangular system of coordinates. So we know Laplace equation is del square V equals to 0. Also, in the question, voltage is a function of x that is specified. So we can write the del square V in general for rectangular system or Cartesian system of coordinates, which is dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square equals to 0. Since V is a function of only x, these two differentiations will be 0. Thereby, we will get d square V by dx square equals to 0. Now, integrating this with respect to x, we will be removing one function. So, integrating with respect to x will give dv by dx equals to integration of 0 is 0 plus integration constant c1. So, dv by dx is c1. So, let us write dv by dx equals to c1. We will require this later. Then integrating one more time with respect to x will give v, that is v equals to c1x plus c2. Now we know the boundary conditions. We will be applying the boundary conditions as given in the question. So these are the boundary conditions. So let me write this boundary condition and write in terms of here. If I apply this first boundary condition into potential function, so I will be getting 25 volts, 25 equals to C1 into 2 into 10 power minus 2 plus C2. Second thing we need to apply for electric field intensity. For electric field intensity, we know the expression for electric field intensity is minus del V, and we will be writing the formula minus dou V by dou x ax cap plus dou V by dou y ay cap plus dou V by dou z az cap. And also in the question it is given potential V is a function of only x. In that case, differentiation with respect to y and z will be 0. We will be having only one term, that is differentiation with respect to x. So it is minus dv by dx ax cap. So what we have to do here is from this equation, we have this equation. From this equation, dv by dx can be written as c1. So instead of dv by dx, I can write c1. So I'll be writing in place of dv by dx, I can write c1 from this equation. So this equals to minus c1 ax cap. Now we can solve by applying the boundary condition. The second boundary condition can be applied in this case. So the second boundary condition can be applied for this equation, which is the last equation. Thereby we will be getting at x equal to 2 centimeter, electric field is minus 1.5 into 10 power 3 ax cap, which equals to minus c1 ax cap. There is no x variable in this expression. Thereby, we can directly write C1 as this value. We will be getting C1 as 1500. So here in this case, C1 will be equal to 1500 or 1.5 into 10 power 3. We can also write it as 1500. Now applying this C1 in this expression, we can get C2. By applying C1 in this expression, we can get C2. So 25 equals to C1 into 2 centimeter plus C2. So I will be rewriting that 25 equals to C1 into 2 centimeter plus C2. Now applying the C1 value, which is 1500 in this expression, we will be getting C2. So 25 equals to 1500 into 2 into 10 power minus 2 plus C2. So you will get 25 equals to 1500 into 2 centimeter plus C2. So C2 will be 25 minus this 1500 into 2 into 10 power minus 2. 10 power minus 2 and these two zeros can be cancelled. So this will be 30. So C2 is going to be minus 5. So now C1 is 1500, C2 is minus 5. Substituting this, we will be getting the voltage expression. So V is equal to C1 into X plus C2. That is V equals to 1500 X minus 5. So this is the expression for V, and as per the question, this is voltage as a function of X. Sorry. Now in question, we are asked to find voltage at 3 centimeter. So voltage at 3 centimeter can be found as V equals to 1500 into 3 centimeter minus 5. That is going to give, these two will cancel, and we will get 15 into 3 minus 5. So there's 45 minus 5, which is 40 volts. So this is V at X value, which is 3 centimeter. So this is asked in the question. So by applying the boundary conditions, we have found this. So one difference in this case is the boundary conditions are given, one for potential function, another for electric field intensity. So we can write the expression for electric field intensity and potential. So electric field intensity is dV by dx. In the intermediate step, dV by dx we have found to be C1. So we can write that C1, that is electric field intensity in terms of C1, and V also is there in terms of C1 and C2. Applying one boundary condition for potential, another boundary condition for electric field intensity, we will get the constant C1 and C2, and thereby applying the constant C1 and C2, we will get voltage as a function of X. Now at particular value of 3 centimeter, we are asked to find the potential, that is coming out to be 40 volts. I hope you have understood this problem. Thanks for watching the video.